In today's world, the internet has become the backbone of an infinite number of business transactions. Yet even with the exponential growth of e-commerce, there's still a significant limitation to peer-to-peer value transactions. Think about it. Every online transaction between stakeholders requires the involvement of third parties to facilitate the value exchange or to verify, approve, or secure the transaction. This in turn makes peer-to-peer transactions more costly and inefficient than they could actually be. Imagine the opportunities created if there's a technology that could facilitate fast, efficient, and secure peer-to-peer value transactions without the involvement of a third party. That technology does exist, and it's known as the blockchain. Digital currency concepts were developed in the 1990s during the dot-com boom. Unfortunately, none of them could develop a way to inhibit double counting of a digital transaction. This double counting dilemma deemed the original concepts unreliable and limited their adoption. But in 2008, an individual or a group of individuals with the pseudonym Satoshi Nakamoto submitted a white paper that resolved the double counting dilemma through the application of the Bitcoin or blockchain protocol. So what is the blockchain protocol? We'll cover the basics of blockchain to show how it's different to the current paradigm of centralized transactions and what benefits can be derived from it. Consider a traditional transaction. Say A wants to send some money to B electronically. How does this work? Well, the transaction is mediated through, say, a bank to ensure that A's account is debited by the amount he wants to give and B's account is credited by the amount they are to receive. The bank maintains a record of all these transactions in its own master accounts ledger. Central organisations such as banks are known as trusted third parties, and they form the basis for much of the modern economy. There are benefits to this. The identities of individual parties can be verified. There's protection against fraudulent transaction. People can't spend what they don't have. But there are problems too. Every transaction has a middleman, which adds overhead and complexity. There's often a cost associated with transactions, and there are many different centralised third parties who are independent and not in sync with each other, which leads to more inefficiency and more potential for fraud and cost. Blockchain is different. Instead of multiple ledgers, there are one ledger, and everybody has a copy. And because everyone has a copy, all transactions are peer-to-peer. In blockchain, identity and ownership are guaranteed using digital signatures. These use encryption technology and so-called public-private key pairs. Ever seen HTTPS in the browser? That's using digital signature technology. New transactions on the blockchain are distributed to the rest of the network. This updates everyone's copy of pending transactions. Many of these occur simultaneously at any point in time. Unfortunately, due to delays in network propagation and potential fraudulent transactions, this can lead to the transactional information across the network being out of sync. So how do we determine a definitive updated ledger? The synchronization problem is resolved in blockchain using mining, which applies the mathematics of factoring large numbers. Contributing nodes in the network called miners solve mathematical problems unique to their transactional information. This takes actual physical effort and has a real-world cost, and the mathematics guarantees that there are no shortcuts or cheats. The first miner to solve the problem wins. Their solution then gets verified by the rest of the network, and their transaction block will eventually be added to the blockchain. The creation of a new blockchain uniquely links together the entire blockchain history, the new set of transactions, and any identity and ownership information involved to create a new block. This block then gets added to the blockchain. The mathematics behind this whole process makes it virtually impossible to rig the network to make your ledger win. It prevents fraudulent transactions, it prevents tampering with a ledger, and prevents double spending. Due to its many beneficial characteristics, not least of all programmable capabilities, the blockchain protocol enables many potentially disruptive applications that are beneficial to businesses. Some potential applications are shown here. Digital currency and micropayments. The centralized nature of the blockchain facilitates instant transfers of value or remittances regardless of size or location of transaction, at minimal cost or transaction fee. Mpeg services and record keeping of intellectual property and digital assets. Securities. The blockchain protocol provides a tamper-proof, compliant payments network which provides secure avenues for all types of transactions. Smart property and smart contracts. Blockchain has open or programmable characteristics, allowing the possibility of developing digital assets and or self-executing contracts stored on the blockchain without the involvement of middlemen. Imagine a world with a global payments network with zero barrier to entry. Every human being, regardless of gender, race or location, would have equal access to participate in the global financial or e-commerce system through a smartphone. The blockchain revolution, just like the internet revolution, will be disruptive, and it will happen. It is only a matter of time.